In this video, we're going to focus on identifying chiral centers and also determining the number of stereoisomers in a molecule and how to tell if a molecule is chiral or achiral. So let's go ahead and begin. Looking at this particular molecule, are there any chiral centers? A chiral center, also known as an asymmetric carbon, is basically a carbon that has 4 different groups. Now, let's look at this first carbon. It's a primary carbon, which means that it has 3 hydrogens. So it doesn't have 4 different groups attached to it, so it's not chiral. Here we have a secondary carbon, which has 2 hydrogens. That's not chiral either. Now, looking at this one, we do have a tertiary carbon with only 1 hydrogen. Is that a chiral center? It turns out that it's not a chiral center. The reason being is this carbon has 2 ethyl groups. So it doesn't have 4 different groups. If you draw it out, it would look something like this. We have a methyl group below it. We have an ethyl group on the right side, another ethyl group on the left side, and the invisible hydrogen. So as you can see, this carbon does not have 4 different groups. So what we have is an achiral carbon. Now what about this molecule? Are there any chiral centers in it? The carbon of interest is the carbon that has the bromine atom. The real question is, does that carbon have 4 different groups? Well, let's find out. Keep in mind there's a hydrogen here. So that carbon has a bromine, a hydrogen, a methyl, and it has a propyl group. So this particular carbon has 4 different groups, which means that it's a chiral center. Now, how many stereoisomers do we have for this particular molecule? The number of potential stereoisomers is equal to 2 to the n. That's the maximum number of stereoisomers that you can have, where n is the number of chiral centers. So since we have 1 chiral center, we can have up to 2 stereoisomers. Let's draw the 2 potential stereoisomers. We can put the bromine atom in the front, that is on the wedge, or on the dash, where it's in the back, it's extended behind the paper. How would you describe the relationship between these 2 molecules? These are stereoisomers. Stereoisomers are basically isomers that are connected the same way, but are arranged in space differently. These 2 are known as enantiomers. They are mirror images of each other. That is, they're non-superposable mirror images. Think of your left hand and your right hand. They look similar, but your left hand is a mirror image of your right hand. You can't really place your right hand directly on your left hand. It won't be the same. So that's an example of an enantiomer. Now let's try another example. How many chiral centers are present in this molecule? Feel free to pause the video and work on this example. So this is a chiral center. We have an OH group, a methyl group, this entire group on the left side, and a hydrogen. Now, so what other chiral centers do we have? The secondary carbons in the middle will never be chiral centers because they have 2 hydrogens. And any methyl group at the end will never be a chiral center. Now, let's check this tertiary carbon. If you can identify any tertiary carbons, those are potential chiral centers. A tertiary carbon is a carbon that is attached to 3 other carbon atoms. So notice that this side here is different than this side, which is different than that side. So therefore, we could say that these 3 carbon atoms connected to our potential chiral center are different. None of them are the same. Here we have a secondary carbon. This is secondary. This is tertiary. And these 2 secondary carbons are different from each other. They're in different chemical environments. This one is close to the OH group. The other one is not. Plus we have a hydrogen. So this carbon has 4 different groups, which means that it's a chiral center. Now what about this particular carbon? Is it a chiral center too? We have a methyl group. There's a hydrogen. Now looking at these 2 carbon atoms, are they identical or are they different? Well, this one is a secondary carbon. This is tertiary, so they're different. This carbon has 4 different groups, so it's another chiral center. Now, how many stereo centers, or rather, how many stereoisomers can we have in this molecule? What is the maximum number of stereoisomers? The maximum number is 2 to the n. And since we have 3 chiral centers, it's going to be 2 to the 3rd power, which is 2 times 2 times 2, 3 times. So we can have up to 8 potential stereoisomers. Now, keep in mind, the configuration of every chiral center can either be R or S. So let's see how we can have a total of 8 potential stereoisomers. Now, each chiral center can have a configuration of RRR, or it could be RRS, RSR, or RSS. The first one could be S, and the other 2 can be S, or it can be SSR, SRS, or SRR. So as you can see, we have 8 different combinations. So we can have up to 8 potential stereoisomers. Now sometimes you need to be able to determine if a molecule is chiral or if it's achiral. So butane, would you describe it as a chiral molecule or an achiral molecule? Butane looks like this. Typically, if there's a line of symmetry, then what you have is an achiral molecule. So butane is achiral. There's a line of symmetry. Also, there's no chiral centers in this molecule. For you to have a chiral molecule, there has to be at least 1 chiral center. So what about this example? Is it chiral or achiral? Notice that we have a chiral carbon. The carbon has an alcohol, a methyl group, an ethyl group, and a hydrogen. Typically, whenever you have 1 chiral center, the molecule is going to be a chiral molecule. As you can see, there's no line of symmetry that we can draw. If we draw the line here, even though these 2 may appear to be symmetrical across that line, we don't have an OH group on the opposite side. So this is a chiral molecule due to the lack of symmetry. Now what about this molecule? Is it chiral or achiral? What would you say? Now notice that we have 2 chiral centers. This carbon is chiral. It has a bromine, a methyl, a hydrogen, and another group. So this other carbon is chiral too. Now when you have 2 chiral centers, the molecule may or may not be chiral depending on if there's symmetry. And we do have a line of symmetry, so therefore we could say this is an achiral molecule. Now what if we drew it this way? Is it chiral or achiral? Now notice that this chlorine is not symmetrical to the other one because one is in the front, the other is in the back. So this molecule is chiral. By the way, what is the relationship between these two compounds? How would you describe them? Both of them are achiral. These two molecules are known as meso compounds. Meso compounds have an internal plane of symmetry, and these two compounds are identical. They're the same. Now, what about this one? What is the relationship between these two molecules? Those two molecules are known as enantiomers. Notice that all of the chiral centers change their configuration, and also there's a lack of symmetry. So whenever you have a chiral molecule where the configuration of each chiral center changes, those two molecules are known as enantiomers.